Hello, this is Mr. Turner, and I assume that you've seen the video of the neat reactions of what a precipitate is. A precipitate reaction is what you just also saw during the lab that you did right before this. So, as you notice that some of the mixtures uh, that were put together uh, created a solution, but there wasn't really anything different that happened. So say we had one mixture that was, let me say this is one liquid right here. Okay, this is, I don't know, a solution with sodium chloride in it. Okay, aqueous solution means that it was mixed in with water, so you have the salt mixed into the water. And another solution had another salt. Let's say that salt was ammonium, I don't know. I'm just making stuff up. Ammonium bromide. Okay. And the only reason I'm saying making this stuff up because I kind of know how these compounds will react. This is also aqueous. So you mix these two together, and you notice that it has made a bigger, you know, mixture of water right here. So you got a solution. But for some, you notice that when you mix the two liquids together, whatever those two were, you got something that formed at the bottom. Okay, that or something that formed at all. That's called a precipitation. Okay, we're going to talk about that. So, precipitation is a kind of a heterogeneous mixture that you can tell the difference. Most of the time, when you have a precipitation reaction, you have this part, the precipitate, which is a solid substance, and then you have the rest of it, which will be a liquid substance, uh, a compound dissolved in the water, which is called aqueous, which means dissolved. Misspelling that in water. So that's what that means. Dissolved in water. All right. So um, how can you tell now? Because there's two compounds mixed in. Okay. Uh, there's two compounds in these mixtures. All right. We have sodium chloride, and we have another one which is ammonium bromide. And every one of these solutions that you mixed, there's two compounds, and a compound. This is going to be called a double replacement reaction. Whoa, you saw that guy. You just saw him. Okay, let me do this here. Double replacement reaction. Let me see. Let me go off to something. Okay, let me do this here. I'm trying to find a good picture I can explain very quickly um, what you need to know. Okay, this one's good right here. All right, let me. You know what? I'm just do like this here. Okay, I'm just gonna steal this real quick. All right, so double replacement reaction occurs when we have two cations, which are positive ions. Okay, positive ions swap their anions. Okay, which are the negative ones. Okay, so these right here, they swap, um, and then they basically reform partners. So again, a double replacement reaction occurs when two cations or anions swap places in a reaction to form two new compounds. In this reaction, A and B are both cations, and they swap their anionic partners. So it's kind of like you know, some kind of when they have certain dances, like this little square dance. I don't know, y'all probably don't even keep up with that. But those, people like have big groups, and you see them in those little musicals or whatever, and the guys and girls will be dancing. They switch. Well, think about it like this, okay? They're gonna switch, and they're gonna connect with the opposite in the pair. Okay, they used to have a show called Wife Swap where that used to kind of be, you know, where they just basically for a day or two, the moms would go to a different household and be the mom of that new house. So basically, that's what's happening here. A is getting with Y, so we see that over here, and B is getting with X. So we're going to see that over here. Okay, when both of them are easily dissolvable, then they're going to come out aqueous. Okay, and when you see aqueous solution, okay, for example this compound, maybe maybe it's just going to be liquidy. You're not going to see any difference. But when one of the compounds forms something that they call insoluble, okay, then that's going to produce a solid. Okay, so there's a lot of terms for that. Insoluble means, okay, I don't know if I'm spelling right, but insoluble means it doesn't mix, which also means it's going to be solid. Okay, a solid inside of that liquid, which also means it's going to be a precipitate. So all those words mean that one thing. So the cool things that you saw or the little changes in the color came from the insoluble compound that was formed when it mixed in with the aqueous compound. Okay, so you got a liquidy part and you got a solid part. So, man, there's a lot. Oh no, you're getting overload in your mind. Okay, on your periodic table, um, there's a part on the back that we have not even talked about up to this point. Now it's blank, it doesn't look like this at all. And you may have your copy, or a copy may be given to you by your teacher, and they may actually ask you to draw this out. I don't know if they will or not. But this is what you need to understand. Each of these ions here, each of these pieces of these compounds, ionic compounds that are positive, negative, are going to, at this level, form aqueous compounds. What does that mean? Aqueous means that it's going to be soluble. It means it mixes. It mixes with water, and what you're going to see is just nothing. It's going to be a clear liquid. Um, so they have no exceptions. That means there's not going to be anything to get with that's going to reverse that. So this is called a common exception or reverse zone. So they're always aqueous. Okay, the second level, bromide, and by the way, let me just say the names of some of these here so at least you know that this is called uh, ammonium, this is nitrate, this is cyanide, this is hypochlorite, this is chlorite, this is this is hypochlorite, chlorite, perchlorate, chlorite, and chlorate. All right. So this second zone here is going to be considered aqueous most of the time. So most of the time they make liquid compounds. They dissolve easily in water, and they're just basically going to break apart, except for if they get with any of these ions. So silver, which is Ag, lead, or mercury. These are heavier metals, and when they connect with the anions, then they're going to clump together and make solids. They're going to be insoluble. So when any of these, okay, get with any of the ones that I have over here, Ag, Pb, and Hg, they're going to produce, okay, a solid. They're going to produce a solid substance. So they're going to actually reverse course and become S, which means not soluble, but means insoluble. So that's what that means. Now, down here, these ions like to form compounds that do not mix, that make solid precipitates, carbonate, phosphate, uh, chromate, dichromate. Okay, but When they get with ammonium, when they get with any element that's in group one, okay, group one would be any of the ones that are here on that first part of the periodic table. Then they will flip and become aqueous. They will become dissolvable in water. So alkali metals are like sodium, potassium, lithium, stuff like that. They are missing them out. So those pretty much those usually. Anytime you see NaKli in the formula, it's automatically aqueous. It's automatically going to be dissolvable in water, and nothing interesting is going to show up as a result. Now, at the very bottom, we have over here. At the very bottom, we have hydroxide and sulfide. They definitely want to form solid substances. They want to form precipitates, but they will swap. They will swap if you have ammonium. Okay, ammonium NH4. It's always going to be dissolved in water. It's going to be aqueous. Calcium, strontium, bromium. Okay, all those are group two metals. Okay, when they get with group two metals, then that flips them and they become aqueous. Okay, they become aqueous means dissolved in water. Okay, so let's practice just super quick, super quick. Okay, so you got K plus. Let's see. Let me see. KNO3. All right. So you got KNO3. Now, a couple ways to look at it. You can automatically break them apart. Boom. Okay. This is going way back to last semester, but on the periodic table, this has a plus one charge, and on the back of your periodic table, this has a negative one charge or negative. Sometimes you'll see it like that. The anion, which is the second one, will usually be the one that you can look at all the time. Nitrate. If I look at nitrate, I'm going to see that nitrate is right here. And if it's right there, that means that it's always aqueous. So when this shows up, okay, we can just go ahead and slap aqueous because when you put this compound in water, okay, it's going to dissolve no matter what. So nothing interesting is going to happen there. The other thing you can also look at is, do you have a group one metal? Because if you do, AQ. If it's in group one, slap AQ because it's not going to be interesting. You're just going to see liquidy liquid, nothing that you want to see. Okay. Let's try another one. Let's try this one here. Calcium. Calcium hydroxide, CaOH. Okay, split up. Boom. Look at your periodic table. Okay, boom, boom, boom. You should see a plus two for calcium at the top. Hydroxide on the back of your paper. Okay, you see minus one, boom, or minus. That's telling you right there, okay, what the charges are. Look at the anion first. What does hydroxide want to do? Hydroxide wants to be a solid. Okay, it wants to be a solid. Okay, so we're gonna say it's a solid, but we gotta look at the common exception. And one of the common exceptions is if hydroxide gets with calcium, boom, it switches it and makes it become aqueous. So therefore, if we go over here, hydroxide basically, because it's connected with calcium, is going to flip. Okay, it wants to be a solid, but because it's connected with calcium, it's going to be AQ. All right, so let me do some little little. All right, let me try. Let's try one more. Let's try one more. Okay. Now, let's see if we have something like um, let's try silver chloride. Okay, so chloride likes to be aqueous based on what we see here. Okay, chloride likes to be aqueous. Okay, that's what it likes to be. However, you got to look at the exception list. Do I see AG in the list? Let's see here. Boom, 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 boom. I do. Okay, so that flips it. So while chloride would like to be aqueous, okay, and I forgot. Got your -1. Got your actually +1. Okay, AG flips it. Okay, so it's going to make this become, okay, instead of AQ, it's going to become a solid. Okay, so you got to look at what's happening. You got to look at what's happening. Look at the anion, which is the negative one, first. Okay, then look at, what does it like to do? Okay, then look at the cation second. Okay, so look at the cation second, and then if the cation is an exception, it's going to flip it. Exceptions reverse what you want it to be. Okay, exceptions flip or reverse what you want the compound to be. Okay, so to recap, in the middle at the top, these ions always want to be aqueous. In the middle, the compounds want to be aqueous, but if they get with Ag, Pb, or Hg, silver, lead, or mercury, they're going to be solids or inside, but they don't mix. They form solids in the mixture. They don't dissolve. Down here, they want to not dissolve. They want to be solid, precipitate particles. But the first group, okay, they're going to basically flip. When I say first group, I mean actually the third. Okay, if we had this number, like a 1, we had this as a 2, we have this, whoa, as a 3, we have this as a 4. Okay, let me go back. Sorry, y'all. So if this was a 1, 1, okay, if this was group 2, if this is group 3, and this was group 4. Okay, so group 1, always aqueous no matter what they get, whatever ion they get with, that's positive, cation. Group 2, aqueous most of the time except for when they get with Ag, Pb, and Hg. Group 3, they want to be solid, insoluble precipitates except for when they get with ammonium or any group 1 metal, any alkaline metal. And number 4, they want to be solids as well except for when they get with group 2 elements, ammonium, and things like that. So basically, those are some of the rules that you need to use to help you. I know this is, a lot of technical information, but you can do it. I believe you can. And if you have any questions, ask the teacher in the classroom.